Hey, and welcome to the first live stream on my channel. My name is Kevin. I'm a mobile advocate for SAP, and I'm focusing a lot on Swift and iOS development, as you know from other videos on my channel. And I get to ask to talk about Swift, the programming language in general, and just give a small introduction to it so it's easier for people who want to get into iOS development to get started. Um, Everything I'm going to show you is pretty much the structure, kind of the structure of the Swift language website, like the official documentation. I took that and just built my own examples just to show you what's going on here. A great tool for learning Swift is Swift Playgrounds, right? And Swift Playgrounds, as you know, it's just a feature in Xcode. So it means if you want to do iOS development or Swift development, in that case, you might want to have Xcode on a Mac, and then you can go for it. So what we have here is our Playgrounds file, and Playgrounds is pretty cool because we can just say run, and it usually just prints out whatever the result is here, right? So we see hello playground, right? So before we get started with actually going into detail, let's talk about what is Swift. Swift is a strongly typed, object-oriented programming language, right? And in Swift, if you write a single line of code like this here, this is considered a full program in Swift, right? That means you don't need a main method for program entry or anything, as those statements here are globally known to the Swift compiler, and it can run it, and it's just a program right away. So let's get started with Swift. The first thing I think you should know is the difference between a var and a let. So as in other programming language, we have variables and constants, and that's pretty much what a var and a let is, right? We can, for example, say let name is Kevin, and if we run that now, we should not get a compile time error. Should be fine. Yep, and we see this constant name stores Kevin. We could also do a variable, right? Other name, and we just call that I don't know, let's call it Peter. And now we stored that string Peter in a variable. Okay, so no, what is the difference? As I said, a let is a constant, a var is a variable. So if I try to actually assign a different string to name, let's say we want to assign Thomas here, and we would run that, we get a compile time error which says cannot assign to value name is a let constant. So the compiler actually lets us know, oh, dude, you're trying to access this constant and change the value of it. That's not allowed. So what we're going to do is we can change that if we want to change that string to a var, or we just, in that case, use our other name variable. And here we can do things like other name equals, I don't know, max. And if we run that now, it should be fine. The compiler should be happy with that. And we see, okay, our variable is max now. And we can confirm that by just printing other name again. And we should actually see it's printing out, should print out max. There you go. So those are just lets and vars, super important to know the difference. You will use them a lot, obviously. But more important are also the data types, right? So we have different data types here. So let's get rid of that. Or actually, let's just leave it. And for the data types, we have different data types. Like basically, we have like the data types we also have like in Java or other programming languages. We just gotta remember Swift is a strongly typed language, so it's really, really hard for you to actually mess something up here. The compiler usually reminds you that you did something wrong. Also, data types in Swift are structs, and I'm going to talk about structs in a different live stream, but they're basically structs and classes. And classes, as you know, those are objects, and the reference is pointing to that object. And a struct is pretty much, as it sounds like, it's like if you would imagine a model where you want to store some data, you would put that in a struct in Swift, and this is copy by value. Like there's no references to that struct. If you move that struct around or pass it in somewhere, usually I always puts in a copy of that struct, so you never manipulate the original directly. So anyway, that was just a small excursus. Let's talk about the different data types and string interpolation. Let's just quickly, because we're talking about strings, let's just go into the string interpolation real quick. Let's just create another string variable called cat, and as you saw, we can print out our string here. We did that up here as well, but we can also manipulate and count the characters. We can do all sorts of things with strings here. So we could do print, animal dot count, and then it should actually print us out the number of characters in that string. Then we can do, if you want to append another string to that string, for example, we can do that as well. We can just say animal dot append, and I don't know if you know that show from back then, the cat dog. I watched that show a lot when I was younger. So let's just create our own cat dog here. So let's do that and print our new animal out. Let's see. And we actually see, okay, we have cat dog here. Now we have a cat dog. Let's just quickly check the chat. Okay. So Thomas is saying let var, that's interesting, as JavaScript also has let and var, but in that case, let is a very different. It's a block scoped variable instead of a constant. That's interesting. It's good to know if I ever have to write some JavaScript code. Where was it? Let's just okay. Now what happens if we're not happy with our concatenated string and we want to remove, for example, the cat from it because I'm a dog guy. I like dogs better. So let's just do animal remove, and then we can say subrange, and you see it expects an range expression. So we just say remove subrange, and then we can say animal dot start index ranges all the way to animal dot index, and then we can say to the start, to the start index, and we want an offset here because we only want to remove the cat, and then we should actually have just a dog here. And you don't have to understand that statement like fully like right away. It's just like to show you what is possible. So yeah, we got our dog back. Or actually we transformed the cat to a cat dog, removed the cat, and now we got a dog again. So we can do things like that. If you just want to temporarily add a string to another string and just print it out or log it or whatever, you can do that as well. We can just concatenate those as well. So we should say print, and we have a string in here, and now we can say we add the cat again, and this notation here allows you to put a variable inside of a string, and Swift will take care of the rest here. Of course, this is a string, so Swift doesn't have to do much here. But if that would be an int, it would print out the integer value, right? So we can do things like that. And now we got should get the cat dog again. Yep, there you go. Yeah, let's play around with the strings a little bit more. Let's just see how we can print out different strings in different ways. So let's say we have a statement here to our cat dog, and we actually want to build a whole sentence. And once our sentence is weird, because the cat dog is kind of weird, right? So we just print that out again, and there are two types of how we can do that. You know this annotation there, this annotation. So we can say this is our animal, and here we got our statement. So if we would print that out, we should actually see, yep, dog is weird. Why is it a dog? Because we just added cat temporarily to it. Forgot about that, but it's all right. Let's change that because dogs are not weird. Dog is cool. Let's do that. All right. So a different way to write that would be to say we just take the variables we have, which has our string values here, and then we can just do, actually that's wrong. We can just do animal plus, we want an empty string, right? Plus, and then we put our statement in here. That's like another way how you can do that. Also notice that that space character here, as a space is a character, Swift can interpret it as, properly as a space character, so the sentence is going to look proper. All right, now we got strings. You can of course do a lot more with strings. You could also, that's kind of cool actually. You could also embed emojis if you want to directly into your code. It's kind of cool. So let's just try that. And here we just say edit emojis, and I need a dog. So we couldn't do that, I think. No, okay, we need the code for that. But that's fine. You can look that up online. But you can also just put emoji codes in here, and then Swift knows how to see that and build a sentence out of it, or build a string out of it. Anyway, let's go floats and doubles. In the business world, I think we need floats and doubles because we're working with money and we're working with accuracy and all those kinds of things, locations and so on. So floats and doubles are pretty much just, as in other programming languages, just a data type to store numbers with a fractional component in it. You can choose either a float or a double. A double has higher accuracy as a float. So I think I read somewhere in the official documentation that it's mostly recommended to go for double, and that if you're using a float, you actually got to think about why and if it's really necessary to use that float, or you're not better off using a double. But let's just do that. Let's just implement a location. Let's just say we have a latitude, which is a double, and our latitude will get a value here, and I will talk about that piece of code in a second. And we just say it's 1.66667, something like that. Also, we have longitude, which is a float in our case here, just to show you. And this kind of is going to be, I don't know, 86.78350. All right. So this notation here, bar latitude double, this just means we have a variable with the name latitude, and we explicitly tell the Swift compiler we want to store a double in here. The same for the float. The Swift compiler usually, or actually is smart enough to infer the type from whatever you store in a variable or a let, or but sometimes you want to explicitly tell it, hey, this latitude variable is only allowed to get doubles, which makes total sense in this case, right? So that's just another security step to make sure everything's good. All right, let's just see the difference between double and float, and the easiest way to do that is just to run that real quick and see the result. And we see here our full value. And now we're just taking this longitude float and just make it longer, and then you see that the accuracy decreases. So let's just do that. And let's copy that 3 times, and just every time put like a number in front of it and run that again, and you will see it will cut off the last numbers here, and it starts rounding, right? So that's what I meant with accuracy. If you need like an accuracy which is pretty high, you want to use double. If you're happy with I mean like just a smaller number, you can go for float. All right, Booleans. Everyone knows Booleans. In Swift, it's called a bool. A bool can be true or false. So let's say is animal hungry? Now our animal is not hungry, and you can see it's just a false in that case. And of course, with a variable, we can change that value. And you know how Booleans work. So there's just the true or false. I don't know if that's the same case in ABAP, but I heard that in ABAP there are multiple ways to declare a bool. Here you just have true or false. Let's go to type annotations. And I was talking about type annotations a little bit in between. But as I said, the compiler usually knows what type of data you store in a variable or constant. And that's because it can do type inference here. But sometimes you want, as above with the latitude and longitude, you want to annotate what kind of data you want to use here. And that means you cannot change the type of the variable later on. That means if you have like this latitude double, and there's a double in there, and you want to use that latitude later on and change it, you got to put a double in there. The compiler will let you know. So you're doing something wrong if you don't put a double in there. So let's just go to cars. I like cars. Mercedes is my favorite manufacturer. And as I said, Swift does type interference, so it knows car is a string. But we also could do var car string and then assign our Mercedes to it, right? The same code, it's the same result. So what shows us, that shows us that type annotations we really only need if we don't assign a value straight away, or if we want to make sure that actually read that data type is in that variable stored. And that's true to all types. So we can do horsepower, which could be, I don't know, 360. And then let's check if it's an AMG. Of course it is, because we just buy the best. And then we, for example, I don't know, we have a GPS coordinate, again, which just has one value, whatever. So you see, Swift compiler can infer all those types automatically, which is quite cool. Oh, ABAP don't has a Boolean at all. Okay. Don't get us started on ABAP Boolean. Okay, I'm sorry. Oh, Frank, yeah, totally. That's right, I forgot the quotes. So yeah, emojis work fine, but you gotta put them in quotes. It's true. All right, let's see, what do we do here? Yeah, so as I said, type inference built in Swift, pretty cool. One thing you gotta know, sometimes there are exceptions. For example, with a double and a float. Even if you put a float value into a variable which was supposed to be a double, it will always infer a double. That's important to know. And there's special cases as well sometimes, and you can read them in the official Swift documentation, and I will put a link in the recording So you find that pretty easy. Let's just puts another just latitude for that car in. So you see we can also do things like that. We can annotate our variable with a double and then assign a value. That's also what you can do. So there are all those different ways you can declare variables and constants. Let's go to operators. So like in many programming languages, you need operators to do calculations, to do math, to concatenate strings, to do all sorts of things, right? Comparisons, all those kinds of things. So in Swift, we have the plus, the minus, multiply, and divide operator, as well as the assign to, which is just the equal. So let's just put some code down to see what's happening here. So let's say we have some product and it has stock. We say we have 10 of that product. And now we could do calculations stock plus 5, or we can do stock equals stock minus 5. And let's just keep continuing that for multiply, and divide. So that works. That's totally valid Swift code. It's a little bit cumbersome to write it like that. So what we can do actually is we can use a different way to write that code. So we could also say stock plus equals 5, right? And we can say stock minus equals 5 and multiply and divide. Completely legit Swift code. Does the same, it gives us the same result, just shorter annotation of that piece of code. In Swift, we call that this equal sign here, we call that an assign to. This here we call a add to, subtract from, like, and so on. You get the idea, right? So let's actually do some calculations here. Let's say we have a bought amount, which is 2, and now we want to calculate our new stock. So let's just say stock minus bought amount. So just basic operations you can do with that, right? Let's experiment with that a little bit just to see how the Swift compiler behaves here. What's going on? Be happy with me. There you go. Okay, let's try that. What would happen if we would subtract a double from an integer? Let's try that. Let's call that a mystery number. And now we say 10 minus 4.3. Let's just run that real quick. And we see we have 5.7. So Swift knows you're subtracting a number here, which could be a double or float, and so subtracted from an integer, which is 10. And as I said before, the result is going to be another double or float. And as Swift always infers as a double, we will get a result of double, right? So what about if we want an integer, even if we subtract a double here? We can try different things, right? We can just try saying we're doing type annotation, right? Because we're guessing Swift is doing the right thing here. So let's comment that out, copy that line of code, and let's just declare it as an int and see what happens. And we get a compile time error. It says cannot convert value of type double to specified type int, because Swift is type safe. It's not guessing what you want here. It's just letting you know, dude, you're doing something which is like, I need more information to actually do something with that, because you're just trying to subtract this double value or whatever it is from my integer, and you declare you want an integer. I don't know how you want to round that value later on, so please let me know. And we can actually do that because we have a method called rounded. What's called rounded. So we can do something like this. Int 10 minus int, and before, that's actually something I just remembered before I show you the round. We can try to cast that, right? We can just say we want to cast that rounding number. Let's just declare that rounding number so I don't have to type that all the time. Which is the 4.3. And we can actually create an integer, and it can take this rounding number. Oops. And it will do the right thing here. We'll create an int out of this routing number, and we see we actually got an int. The compile time errors are gone. But what Swift does is it basically rounds up because we had the value 4.3. So what if we wanna actually tell Swift compiler how to actually round the number, and we can do that. We can say var rounded exciting number, which is an int. And actually at this point we don't have to do the type annotation anymore, but anyway, 10 minus, and then we can actually say int, and then we can tell that how it should be rounded, right? And here we can do all sorts of things, right? You can do away from 0 down to the nearest, or away from 0 to nearest, or even towards 0, or up. Just to make it different, we just say up, and it should actually see that 4.3 is a 5 now. So let's run that. There you go. So this is how you can use operators to actually calculate things or assign things and so on. It's pretty cool. But you also can use those operators, and we saw that before, for strings. So let's just do that again. First name, Kevin. Nice. Kevin. Then we have my last name, which is Music. And now we can, like we saw before, just use those operators to concatenate those. Right? So operators are pretty cool, super helpful. You got to know them. One of the last operators I want to show you here is the modulus, and you know the modulus maybe from other programming languages. It pretty much works the same way here. Modulus just basically means, for those who don't know, it's divide the left number evenly by the right number and return the result. So how does this look like? Var x is 10, and then we have a var result, which is x modulo 3, and let's see what our result is. Cool, we got a 1. So why do we got 1? Because 10 divided by 3, like you can divide, if you divide 10 by 3, you have like 9, like it fits 3 times in there, and with the 9 you have like 1 left, so it's 1. I know I suck at explaining things like that, but I think you get the idea what I mean. So we have result 2, and then we can do the same thing, modulo 5. And can you guess what we should get here? Of course, a 0. And yeah, you can use modulus as well here. Now we want to look at the comparison operators. Comparison operators are important for your program flow. Let's just declare a couple of variables we're going to use for that. So we have variable A with variable B with 7.3, and then we have variable C, and then we just say A plus B here. And now we can do C bigger than 10. We can do C bigger, equal 10. We can do C bigger 5. We can do C smaller 5. And let's just run that. And we should actually see some Boolean values showing up here telling us if that's whether true or false. So we can see true, true, and false. So this is basically how you can use those comparison operators here, and we can use them for all sorts of data types. So let's just get a string again, and I'm Kevin Music, and now we can say, are we really Kevin Music? Oops. Right, with the equal equal. And it says true, of course, because the strings are the same. Now we can also have a not operator to make our expression negative. So we can say, is this cool? And now we can say true. And then of course we can just say not is cool. And that should give us a false. You see? Pretty simple. All right, the last two things I want to talk about before we can go into some questions, or I can show you a little bit more. That's up to you. But we have two more topics. We have arrays and dictionaries. Arrays in Swift are basically a group of values put into an array in a structured way, right? So it knows its position in that list of values, and with help of the index, you can access those values. So how do we declare an array? So let's say we have animals this time, and now we can just say this is an array. And then in here we have dog, and we have a cat, and we have a horse, and we have a dragon, and we have a rabbit. And now we can do a lot of cool things with those arrays. First of all, let's just see how type inference works with arrays. So we can say, just to check type of animals, and let's see what our compiler tells us what that is. Here, see, we can see in here we have an array of string type. So that's pretty cool. It knows automatically we're putting strings in there. That's pretty important. Same for integers, right? Lottery numbers. I don't know. Let's do 4, 10, 23, 56. I think in Germany it's 6 numbers for the lottery. Let's do 4. I don't know. 2. Whatever. Something like that. And we can do the same thing, right? We can just say type of, and it knows that this is an array of integers. All right, cool. So we know type inference works on our strings as well. See, there's a question: is there also a type safe equals? You mean if I compare a string to an integer? You mean? Or what do you mean? Like if we would have I don't know. Let's just compare a equals is cool, and that actually should have cannot convert value of type double to expected argument type bool. I mean, you only can compare data types that are the same. The compiler will let you know because we're super type safe here. I don't know if that's answering your question, Dami, but let me know if not. Right. I was saying that we can use an index to actually access an array here. So let's just get out the dragon, and then we can say animals, and the dragon would be 0, 1, 2, 3. So let's do that. And we should see we got a dragon out here. This is how you access values via an index. All right, so what would happen if you assign some data type to a string array, which is not a string? Of course, we know the compiler is going to let us know, but let's just see. So let's just do, not the movie part, it's a little bit later. Just use the lottery numbers, and let's say on 0, we want to have true. And the compiler should let us know. Cannot assign value of type bool to subscript of type string. So we see we're type safe here. It's really, really hard to mess something up here. How about changing values in an array? Let's just take another example. We have, let me just copy that from my notes because I'm going to type all that. Let's say we have movies, which is a string array. This is, by the way, how to annotate that. And we have like Pulp Fiction, we have Star Wars Return of the Jedi, and we have Lord of the Rings. So now we're a bunch of nerds, and we want that Lord of the Rings to be the Fellowship of the Ring. Like, we want to be more specific so we can access this movie Lord of the Rings by its index and then just assign a new string value here. And now if we want to print movies on 2, we should actually see the changed value. Yeah, there you go. You see it also in the console, Lord of the Rings, the Fellowship of the Ring. Other ways of creating arrays, I'm going to show you just some couple of other ways here. So we have var songs, for example, and then you saw that we can annotate that with string array and just initialize it as an empty array. We could also say we have artists, which we also annotate as a string array, but this time we assign an empty array like that. We could also do that, right? Then what else could we do? Let's see how to put a value into our artists string array without using an index. So let's say we just want to take those values and append them to the last index of the array. Right now our array artist is empty, so I don't have an index of the artist array, so we cannot use an index here. So what we want to do is we want to say artists dot append, and let's just quickly go back to the auto completion. We have append new element, which you see the compiler knows expects a string, or we can also append a sequence, right? That could be an array, that could be also the values of a dictionary, like just a sequence. You can put a sequence in there and it just attaches it. So what we want to do is append new element, and we add title the creator to it, and we print out artists. And we can see title the creator. And of course, it also prints out the debug description. That's the reason why it always looks like that, or it looks like that in this case because it's an array and it's printing a debug description here. It doesn't matter in that case. Yeah, so let's try to actually add another array to our artists, because I don't want to call artists.append all the time. So let's just do that. So we just do artists.append, and this time we say contents off because we want to pass in a sequence, and we declare an array in here, and then we can say, oops, we can say we want to also have Drake in here, also want to have Mac Miller in here. I'm sorry, I'm a hip hop fan. And I don't know, Eminem. And if we print it out again, we should see that we got all the new artists in that array. Build it, do it. There you go. Tyler Creator, Drake, Mac Miller, and Eminem. So that's cool. We can also use basic operators on arrays as well. So if we want to say we have a library and we want to store all songs and movies in that library, or let's say songs is empty, let's just use artists. So we can just do that, artist dot plus movies, and then if we print out, oops, library, we should actually see all of those values being in the new library string array. Yep, there you go. Tyler, the Creator, Drake, McMillan, Eminem, Pop Fiction, Star Wars, and so on. Cool. To our last piece, we want to talk about dictionaries. And dictionaries are unlike arrays, they're not structured because we have key value pairs. So you need a key or the index. And you've got, actually, the index, forget the index, sorry. You need a key to access that value. So let's just take our example from above and create a media library. And our media library, in that case, is going to be key string, value string. So we have this way to declare that. So we can say string, string, right? We just have this in between, and it knows, okay, it's a string, string. And we initiate it. Now we want to fill it with some values. So we say media library equals, and now you can do something like that, right? You can say movie, Harry Potter. And then we can say song, right? Which would be Life is Good, right? And so on. We can do can fill more values in as we wish, like that. Or we could also do something like, let's just comment it out. We could also do something like that, where we say, let's check, artist, and then we have, oops, artist dot first, for example. Let's get the first artist out of that. Like, this is also a valid way to do things. But let's go back. And now, how do I access that? Let's say we want to have the movie. We just say, give me the movie, because we know the movie key is here. We say we want to have a song. We can just simply say song. And if we run that now, we should actually see Harry Potter and Life is Good. And that's pretty much what I wanted to show you today. Let me just recap real quick. So what we learned is basic data types in Swift. We learned basic operators. We learned string interpolation. We learned the difference between a variable and a constant. We learned about type inference. We also learned about how to manipulate values. We learned about type annotation. And we also learned about comparison operators, like those here. And with that, I would go over to Q&A if there are more questions. Otherwise, the next episode will be about, let me just quickly look on my cheat sheet here, what the next episode is actually about. Oops. The next episode is about conditional statements, evaluation of multiple conditions, loops, inner loops, all those beautiful loops we got, switch statements. So it's more about control flow of your actual Swift code for the next time. And yeah, with that, thank you for watching. I hope you had fun. I hope you learned something. As I said, this stream is recorded. It's going to be uploaded later this day. And in the description of the recording, you will find the link to the official Swift documentation. Also, a link to the documentation of Xcode Playgrounds. And then I would encourage you to just take whatever you saw today and learned today and just try it out yourself. Play around with strings, play around with some other data types, do some manipulation. Just get a feeling of how the compiler works, how the compiler helps you, what you can do, what you cannot do. those kind of things. I think I still use Swift Playgrounds if I learn new Swift APIs or new iOS APIs, because the cool thing is, just quickly about Swift Playgrounds, you can not only create just a pure Swift playground like this here, we also can say we want to have, let's open that up, a game. For example, if you're a game developer and you want to try out some calculations, or you want to try out some new crazy engine stuff you've built or whatever, create that game thing. If you work on a map and you want to try out map things, you can also have that. If you building UI, for example, later on, if you want to try out the SAP Cloud Platform SDK for iOS, and you want to try the SAP Fiori framework, which has all the UI components included, and you just want to check them out and see how they look like, and you don't want to create a full-on project and compile and all do those kind of things, create a single view, and instead of having the output rebel on the side, you will have a UI view, right, where you can actually see the UI you build. So Swift Playgrounds is a super helpful little feature in Xcode for you to try out pieces of code. Also, if you have kids at home, Swift Playgrounds has an iPad app, and with that, kids can learn how to develop Swift in a super easy and fun way by programming robots and droids and things like that. And you could theoretically buy one of those Star Wars droids and connect it to it and develop and develop like the path it should walk. So it's a super cool thing. And I encourage you to read the documentation, try the things out, and with that, I want to just check into the chat if there are other questions. If not, I want to conclude this live stream, and I'm thanking you for stopping by and checking it out.